Fractal is a never-ending pattern. It is a complex pattern by repeating itself over and over in an ongoing feedback loop. Welcome to Expound coding. Let's have some fun coding a fractal tree today. Open your favorite code editor. In my case, I am using Visual Studio Code. Create one file called index.html and another called script.js. You can use generated sample HTML code, but we need to link our script.js file and the P5 Javascript library that we are going to use. To find the P5 library CDN, just open your browser and go to cdn.js and search for P5. Then you can find the CDN link. Link it in the HTML code before our script.js file. Open the HTML file on the browser. Okay, it's time to do the coding. Go to your script.js file. To do the canvas drawing part, we are using two functions from P5 library. First one is the setup function. We are going to use it to create the canvas and do the initial configurations. We can use create canvas function to create the canvas, and we can configure the width and the height of the canvas. The other function is the draw function, but before that you can make the background color to black to make the canvas visible. So let's set the stroke color to 255. So in that case you can see your drawings in white on the canvas. So let's try to draw a vertical line. And drawing on the canvas is pretty much playing with the coordinates. As you know, the 0, 0 coordinate in upper left corner. In that case, we need to calculate the coordinates that where we want to start the tree. So x-axis is going towards right, y-axis is going towards the bottom. To draw the line, you have to specify where the line starts and where the line ends. But in that way, it's really hard to calculate our coordinates to draw the tree. So what we can do is use the translate function to set the origin to whatever the coordinate, whatever the point we need. So the coordinate 200, 400 is our origin now. We can consider that as 0, 0, and we can start the tree from there. So likewise, if we try to calculate each point and try to draw point by point, it will take many years to finish our fractal tree. So in that case, to make our code little bit reusable, I'll create a separate method called draw fractal tree. So then we can reuse to draw our branches. Before we try to write the code, we'll try to understand what exactly we need to design. So as I mentioned earlier, a fractal is repeating the pattern again and again. The equation to generate fractals is z square plus c. Both are complex numbers. This is really important if we try to generate fractals, because fractal is not only in trees, it's everywhere in the nature. So in a later tutorial, let's try to use this function and try to generate fractals. But here we are only focusing on generating this fractal tree. This figure shows what we are trying to do here. So we try to repeat the same pattern again and again at the end of each branch. And we have to reduce the length of the line in each level. Let's create the line in our fractal tree function, and we can call that function inside draw function. and length is something we have to reduce each time in each level. So in that case I will pass that as a parameter, then we can multiply that from a factor and we can reduce in each level. And in each time we draw a line, we have to translate that point to the origin. And each new line we have to rotate by a certain angle, and this time I will use pi by 4. And let's start drawing only the right branch at each endpoint. To do that, I have to recursively call the same function again and again, then it will keep drawing the right branch with 45 degrees. This is interesting. So if we don't reduce the length of the line, it will come back to the origin point. So I will multiply the length by a factor to reduce the length. So then we can see the tree starts growing. But if you carefully observe the browser console, you can see one error occurs since it's infinitely called the same again and again. So because of that we have to limit. So we can put a condition like stop drawing if length less than 1. Okay, now it's time to draw the left branch. So we can use the same rotate function, but we have to use a minus angle. So I am going to rotate it by minus 45 degrees. And we recursively call the same function and reduce the length as well. But this is not what we expected. Seems it's creating the left branch at the end of the right branch. So what we can do, we can use push and pop functions to keep the last point we added or remove the last point we added. So in that case, once we go to the end of the right branch, we have to pop it and we have to come back to the beginning of that branch and we have to draw the left branch. To make the performance little better, I will change the condition to be less than 2. Right, this is what we expected. Now it's time to play with the length and the angles. So I'm going to change the angle first to pi by 3. Okay, now it's time to optimize your function. Then we can easily play with changing the length and the angle. At the same time, you can change the right angle and the left angle to different values. And you can change the different lengths for left branch and the right branch. So using those combinations, you can create very different fractal trees.